if you want to start recording, I can see a little red light, so we'll get going. So yeah, thanks everyone for joining us for the Australia and New Zealand PowerShell user group meeting for October. And I should know that because it's sitting right in front of me. We've got a couple of links for you to keep in touch with us. Probably the main one is that ANZPSUG.github.io, because that one's got links to everything else. But yeah, reach us on Twitter, meet up when I can log back into it. Yeah. I've also started to fill out a bit of a schedule on that website for future meetings and put it out a few more months than what I had been doing. So if you're ever interested in claiming a slot and you see that it's empty, just flick me a message and we'll pencil you in. So this user group is co-organised by 3 of us. I'm Josh here in New Zealand, and over in Australia we've got Adam and Shah. Not sure if Adam's online yet, but Shah's hanging out in chat. And you can feel free to get in touch with any of us if you've got questions, comments, requests, you want to volunteer for something. Tonight, we've actually got 2 presentations. We're going to hear from Edd first about PowerShell development with Azure DevOps. And then after that, Mike, who's joining us in the dead of the morning, he's going to be talking PSRemoting. And there's their Twitter handles there if you want to go ahead and follow them or reach out with questions after this. And the only other thing I really want to talk about before we get into it is the PowerShell conference book. Volume 2's just been partially released a week or 2 back. Proceeds from sales of this book and Volume 1 go to the DevOps Collective's on-ramp scholarship, which helps get people basically into the on-ramp track at PowerShell Summit. The scholarship only technically covers domestic travel within the States, but international people, so from New Zealand, Australia, or anywhere, can apply. It's just you might need to either self-fund or get a sponsor or something for the international travel. And it's possible, if they don't fill all of the scholarships, that you can open a dialogue with DevOps Collective and work something out. So if you're interested or know someone, do go ahead and apply, and if you can afford it and want to support the effort, go ahead and buy a copy of the book. I know Adam did a chapter last year. I've got a chapter this year. Yeah, it's a fun project. So first up, we've got Edd. If you want to take over, and as we've seen, it'll kick me out. And I'll go ahead and mute myself.
Mute would really help, wouldn't it? Right, so you should be able to now see a hopefully a simple slide deck, if that's coming through. Cool, right. So I'll try to do this in order, shall we? I'm just someone that talks at people, so you don't really have to listen to me. I'm just here as a friendly chat because I was drunk one night and someone asked for a speaker at a user group. So I thought, yeah, why not? I'm an engineer, which a lot of people say. I'm not the best engineer, so you won't be looking at code today getting best practice because I don't write it. What I do try to do, though, is help people understand what makes their best practice and how they can work better as a team using the technologies that we all know and love. I'm hoping that people will come away today having a slightly better understanding of what makes a good module, not what makes good code, but what makes a good PowerShell module. What is it? What makes a good one? What makes a better one? And what more can we do with it? So we'll go straight into it. The first thing is, as a lot of people may already know, a PowerShell module in its shortest form, smallest form, is code saved in PowerShell format as a PSM1 file. that is all you need. So a lot of people who try to get into PowerShell, who try to get into module development, think it's very, very complicated. That's not a nice module, but it is a module. That is how quickly it is to get started. A slightly better module will have what's called a data file or a manifest, a module manifest, which describes the module, and it allows PowerShell to do some things with it and give you some information about the module before you've actually done anything with it, like what functions does it expose, what version is it, what unique ID does it have, so you don't get confused with other modules, etc. And you can create these files. And there you go. A better module is a module file like you had before and something that describes it. Now, at that point, it's worth taking note that that's fine until you get to very big modules. And there's a lot of code in these files and you're making changes and you're trying to write tests and you're trying to do a lot of work and it's quite hard to develop. So a good module needs to be easy to develop, structured, tested, documented, working and available. And I'll put stars next to available verbally because I never got mine published. So we'll wait and see on that one. Pipelines, another thing that's complicated for a lot of people. What is a pipeline? You hear a lot of CI/CD, DevOps gets a lot of fun buzzwords around it. But pipelines have existed for a very, very long time. And they are just to get something from A to B. You know, you're trying to get even if you are B, you're trying to get the thing that you've made. You're trying to make sure it's what you wanted it to be, the way you want it to be, and in front of the people you want to use it. Otherwise, it's pretty pointless. For me, I am the person that I want to use it, so a lot of my release is to myself, but I still want to make sure that what I've actually said I'm going to build has been built, test that it works, and I can then iteratively improve that. So a lot of people will try and very early get the module as perfect as you're ever going to get it. You won't. If you can get all of the fundamental parts of your pipeline in, though, you can get the minimum amount of your module to work, and then you can spin back round and keep updating little bits with some confidence that you're not going to go and break the last thing that you got working, like I did this morning. So I had a requirement on myself, which I made just after agreeing to do this. What are you going to call it? Show and tell, little demo, that I wanted to be able to develop PowerShell modules from an agreed template with enough startup code that I don't have to go and rewrite the same tests or the same code just to prove that a module in its basic form is working. Otherwise, I will keep writing that code, I will keep writing those tests, and I'll never get to anything that's new. I work a lot in teams and I want consistency because for me, the biggest thing of DevOps is consistency. Without that, you're pretty much failing at everything else. So, if there's no massive questions straight away, I'm just going to flip straight across to the stuff that I made. For this, there are lots of other people making similar. This isn't about this being better or different to anybody else's. It's just something that we can go through the individual stages and talk about how to get to that output, that module file and that PowerShell data file, which is what we believe a good module is. But that's not easy to develop. That's not easy to use for a lot of people. It's not easy to understand. So what you're looking at on my screen at the minute, if it's big enough, is a folder structure that looks a little bit complicated for some people, easier for others. I'll just open it up a little bit. What we need to talk about, when I've finished opening it, is this is essentially just a scaffold. Everything in source has just been written for the purposes of this demo. The bit that I never got round to last night was putting it completely into Plaster, which is a module. For people that don't know, Plaster is a module that allows you to define in a schema of sorts, in an XML file, a config file, what you want your repository structure, your project structure to look like, including files and tokenization. You arguably click go, answer some questions, and what you're supposed to get is a module, or a folder structure rather, scaffolded around that configuration file and the variable information you've provided. So what you're looking at now, hopefully in a couple of weeks, will actually be in a Plaster module where you will be able to just say new PS module and you will answer some questions and get all of the scaffolding that you see in front of you, including some extras for some additional modules. I have a habit of talking too fast, so I've got to slow myself down every now and then. Apologise. So we're writing some code and we know we want to get to a module. this PowerShell data file, I'll just stick to the source at the minute because I don't care about anything else. This is just an empty file because I use a module called Build Helpers from Warren Frame, which helps, by the name, helps us provide certain build information so that you don't have to go and write extra code to say, go find me my module name. When you're building every module, the one thing that is already variable is the name, and there are ways to put the name into the folder structure. You can call files it, you can call folders it, you can then, if you know your structure, you can search for that. But what Warren had to do is say, well, people tend to have different structures, so I'll write some code that understands some of them, and I'll make some assumptions and give them some help to say this is probably your project name if you're following one of these 3 or 4 common practice structures. So this file here is just to give that something to look at. I don't actually use it, and I'll come on to that in a minute. I've got 3 main folders: public, private, and classes. I'm only writing this code to give examples of public, private, and classes to make sure that what I'm writing works. So there we go. Each PowerShell unit of code is in its own file with associated tests. There you go. This is why I said that you're not going to learn the most magical coding from me today. That is the most advanced function I think you'll ever see in your lives. It should be privately useful. It's a private function, and the test should confirm that. Ta-da. And we can even run our tests, which is very important. The red wasn't from this, don't worry. So you get a test, it gets run. Every file has similar tests. I've also thrown a class in there just for the sake of having an example of a class, which again should have associated. Someone asking, or is that just noise? No. Again, everything has tests. Everything works. Everything links together. It's fine. So that gives us the ability in here for anyone to come along and essentially pick what they want to write, public, private, or a class. They could write some help files as well. Create a new fixture, add the code, write the tests, make sure they work. That is all I want to be doing. Everything outside that folder structure is then going to be supporting that. So we've written some code. We've got some tests, everything's fine. That is my source. My source is in Git as source control. I'm using Azure DevOps as my repository. Could have been using GitHub or anything else. That is the source side of my project covered. I've got the ability to write, store, and test locally test code. Because I want to get to the ultimate aim of obviously having some files, I want to get to not all of that. Wow, it's really useful. Excuse me a sec. This will be better. So what I want to get from my code is I want to get to those simple 2 files, but I don't want to cause the developers issues with 2 single files. Trying to write tests and trying to update code that goes in and doesn't break things can be very difficult, especially when you get into a team. As you saw, these bits of code here, they need to end up in a single file, a single PowerShell module file. They need to have certain keywords or certain phrases in that file to export those functions, and the PowerShell data file that associates with it has to have the right version, the right name, the right information, and somewhere the right functions exported. I don't want to do all this myself manually. I don't want to have to keep opening the same file and risk accidentally changing something that already works. I want to just do it in my source, and that's where the build system comes in. Now, hopefully we've got time for this. When it comes to the build part, again, a lot of people will tell you that you've got to go and use a big pipeline system. Maybe it's going to be AppVeyor, or maybe it's going to be Circle CI or Azure DevOps, whatever it's going to be. The truth is, it's just a phase, and there's lots of build tools. I made the choice to go for Saki, which is a PowerShell build system written in PowerShell. There's also Invoke Build, Module Builder, and some other stuff. Excuse me a second. Sorry. There's a lot of other modules for it. I prefer Saki, it's just easier to do. But the idea is that you define build stages, properties and build stages. You tell what you want to do. Do you want to build? Do I want to clean? Do I want to remove any old code from my project repository or any old build artifacts? Do I want to test it? Do I want to analyze it? What is the stage? You create your essentially sections, your stages, your tasks. You tell it what you want to do. You're still writing some custom code. This is the bit that you're looking at. I'm just going to go through it very, very quickly. This is the bit that essentially grabs all the source files, finds out what type they are, writes the code into a single file, and does some bits. Again, the code's not important. You can read through it at your own time. The idea, though, is that you structurally agree what you want to do in stages. You can make a stage call to multiple other stages rather than having to rewrite the same code. The beauty of this is you essentially run your commands. You say, I'm going to have a build system. I've got a build file, which is what I just showed you with Saki. I've got a dependency file. Another module that I'll come on to is PS_depends. To build this module or to build this source, you need lots of other PowerShell modules. Another Warren Frame specialty is he wrote something that will essentially, you put a file together, a requirements file, you tell it what you need. For my project, I'm going to need Saki, I'm going to need a script analyzer, I'm going to need Pasta, and I'm going to need build helpers. When I get round to it, I'll need Platypus as well. And PS_depend will go off, download the modules, put them where you'd like them. In this case, I've kept a local version within the source repository that I can clean up so that I can either pin the version I want or just not litter my machine with stuff coming through. So that's the build system. Very, very quickly, very, very quickly. It's worth looking into because it gives you this at the bottom. It gives me the ability to turn around and say, look, go and call my build script, which is a very simple invocation, give it a config file, give it a place to go and put dependencies, go, make my machine ready to then build the module, and what we come on to in a second is the tests for the module. I appreciate I'm going short on time. Right, so, excuse me. This build Saki script, as I said, will go through, it will do all the bits, it does the test, it does the analyze. When it comes to the build system, a lot of the time you've got to, when it comes to Pasta and script analyzer to a point, because these systems, especially Pasta, are built around the idea of swallowing exceptions if something goes wrong, to give you a failed test and then a message as opposed to just binning out of the tool. You've got to handle some of that, and this is in here as well. And hopefully, if this doesn't break catastrophically, what we're now going to get, if the demo gods are good to us, is the build output that you saw a minute ago that has given me my module file, my version of my module, which has come from that broke really badly, my version of the module that has come from a properties file. What should have happened, although that didn't, got one failed test. Fine. So I've got an issue where I've got too many things with called Saki on my machine, which is fine. But the idea that you would have seen is that by changing the step that you want it to run, you can very, very easily control your system and get it to different parts of your build or your pipeline, and you can retest them. And if this actually does something, it should just go through script analyzer and rattle through all of the script analyzer tests and tell you that I haven't written any bad, dodgy code, hopefully because I didn't write enough of it to be dodgy. And it's not doing anything, so I will. The last bit that I want to quickly rattle through is the other bit on the demo, on the title that talked about Azure DevOps, while this is pretending to build and not do anything. This is all on my local machine, as you've seen. I want to have a consistent experience. Again, consistency. If it ever worked, I'd want every single person to work on this project to be able to run through the pipeline, in quotes, you know, the compilation of the work, the testing of it, the analysis of it, and indeed the publishing of it from their local machine in the same way that any automated build system would work. The idea, in theory, of automated build systems is for teams. It's for letting it do it itself, not on your machine. Click go. I want every time I click go on certain branches for my code to be tested, to be analyzed, to be compiled, to have everything here done and that has just completely died on me. So let's quit that. I want everything to be done for me, and I personally use Azure DevOps for that. And this will be the quickest part you'll ever see in history because it's the easiest part. Everything that I've rabbited onto until now, oh, look at that magic. There's proof that it did sort of work. Everything that we've done now on my local machine, I need to make sure happens all the time, consistently for everyone on my project. So we have Azure DevOps doing that. Azure DevOps is used to be Visual Studio Team Services, Visual Studio Online. It's Microsoft's team development service, if you want to call it that. It's a bit like GitHub, GitLab. There's different parts of it now. They've broken it into main elements where you've got boards for planning your work. You've got, I think it's wrong, repos for storing your work, pipelines for building and releasing your work, artifacts for storing it and sharing it indeed for other people, indeed pulling it into other pipelines. And you've got test plans if you ever get into that level of work. The file you're looking in front is a YAML file, which has been recently added, maybe a year, 2 years, to VSTS or Azure DevOps. It used to be XML and a very weird web GUI. This file is an instruction file. I've got some variables that I will pass through the script, if you like. My triggers say that if I make changes to, if I'm pushing on any of these branches, either master or anything that is under a feature area, then automatically run this. Don't wait for someone to build it for you. I've had to move to Windows because the gallery publishing stuff just does not work on Linux very well. And I moved down the file anyway. This doesn't look the latest. All this is doing in each section that you see here, these are a list of tasks, these will be executed by the pipeline, is I'm calling the same build script that I called locally with similar arguments. In Azure DevOps, on my machine, I'm moving my modules into this subfolder, as I mentioned earlier. It doesn't work very well in Azure pipelines at the minute, updating the PowerShell module path. So I just install all the modules to the current user because it doesn't matter. They're only going to be containers or VMs anyway that get wiped away. So that doesn't really bother me. This file goes down, and as you can see, I am compiling all the work. I'm then testing with Pasta, the thing that failed a minute ago. I'm then testing with Script Analyzer. So I'm using Pasta just to invoke Script Analyzer so that Pasta can then tell me if there's failed results. It's not the only way of doing it. It's just I've already proven that Pasta's working. I may as well use it again with Script Analyzer. I publish the results so that I can actually see them. And the end result is that you have a pipeline that 46 minutes ago actually worked. And what you will get is you will get a long list of your test results if they've been failed, aborted, or passed. And you get to see whether you've got, there you go, unit tests, linting tests, module tests. All of that is the pipeline just running what I want it to run. The bit, arguably the final bit before I get to questions, is something that I really want to loop round to. I showed unit tests. So the developer that's been asked to go write this unit of work, I want a module that looks like this. I want a function that does this work, or a class, whatever that is. What I prefer to do at the top is I have standards tests. So linting is easy. This is just Script Analyzer. You know, there shouldn't be any red squigglies. There shouldn't be any maybe yellow squigglies, depending on how evil you want to be to the people that work with you. You might say that they can't use aliases and things like that. I have some standards tests that are not complete yet. It doesn't matter what module you create. The fact is that there are certain business rules if you want, or certain structural challenges that you want to put to people. There is a test here. You'll see that every single test file has to have, every single function file has to have a tests file. So if someone comes in here and creates a new private function and it doesn't have a test file, fail the build. Nothing stops them putting an empty test file, but that's not the point. This uses the abstract syntax tree badly, but it uses it to go and grab those files, pull in all the code safely, or at least understand what they are, tokenize it, and then say, right, you should only have one of those keywords, whether it's class or function. You should only have one of them, class or function, and should only be one of them. I don't want multiple functions in the files because it can make things a little bit harder to test and find things. And that's what this essentially does. Go find me a keyword, whether it's class or function, and the command name should match the file name. And that's how I know that I'm going to always have consistency through my project. This is a single example of how, even before compiling the module and exporting the help, I look through to make sure they've at least got a synopsis populated. And I'd add more in there saying that I want more structure. I'd loop through all the parameters and say for every parameter there should be a dot parameter, and there should be examples for at least every parameter set. I can write those tests once, and then every single module I create with the scaffold will be tested for the same things, and then the developers don't really have to remember. In short, I would say that is it. As I'm going to ask if anyone's got any time for questions. So we'll get back to this. Quickly loop back through. Build a good module. Start with a template. It doesn't have to be mine. Start with a template. Get enough structure in your place to say, well, here's my build process. I know it's going to work for wherever I put my source. Here are my module level tests. Here's any utilities that I need to help the process. You then get to write code. The bits that we actually enjoy doing, the fun stuff, the stuff that breaks every 2 minutes, because the stuff outside the highlighted should be tested enough to work. The pipeline that we've talked about is Git, in my case PowerShell 7, Visual Studio code, and PowerShell Script Analyzer, which comes in early with that. I was using psdepend, which is a dependency manager, build helpers, which help you find out information about your project without you having to write that code again. Saki, which is a build system, and I put some custom code. The shoulder of giants is Pasta here. I've been using Pasta for a long time, and it's an amazing tool. If you don't learn anything from today, just know that Pasta is an amazing tool for asserting conditions, whether it's in your code, whether it's in your infrastructure, anything you want. I didn't get onto the artifact stage, but it's good because I don't want to eat into Mike's time anyway. The ultimate aim for me, though, is this bottom bit. Once I've got my scaffold and once I've got my repeatable process, I want to create a plaster scaffold so I can invoke a new one, and I can then even use that scaffold for future updates, where I can just invoke the scaffold, get my module as it was, add my new feature, put that to the side, and then test that the scaffold then remakes that feature. The points to note for me when it comes to consistency and quality is I tried to stick to a minimum viable product. There's a lot in this talk. There's a lot of information without a lot of depth, but the message trying to get through to people is I didn't have to write all of this myself. I took other people's code, other people's work, other people's modules, tied it together in a structured approach, and it gave me what I needed. Nice to have, so I left until later. I actually wrote my Pasta tests first, so most of them, so I could show what was and wasn't working, what I hadn't done yet in the project that I knew I needed to come up to for today. And then obviously there is a test phase in any pipeline, but always test. Always try and find a way to make sure that something you've written keeps working. We've talked about the fact that a module needs to be easy to use and develop. For me, that's simply break it down as much as you can into single units of work that can be easily tested, easily understood, and then do some harder work to merge all that together. The pipeline there is to give you confidence that your work is working. And if there's any questions, you can fire them at me. And these are all the modules that so far I've been using and stuff I've been looking at. Bang on time.
That was awesome. Thanks, Ed.
No worries. Do I steal the desktop back, or should we have to stop sharing somewhere?
Good stuff there.
Oh, sure. So, Ed.
Yes.
Is your is that demo module available anywhere at the moment?
So it's going to be on GitHub. The reason why it isn't at the minute is I picked a very, very cool name of PS module. And then when showing someone last night, because I'm a bit silly on this, we decided to look in the gallery because I was about to publish it for today. And there's already one called PS module, but it hasn't been updated in a few years. So I'm going to tweak the name. I'm going to stick it on GitHub and get it published into the module. And then, yes, nice. Every bit of work will be tracked on that. My GitHub is Marv the Robot. It's very empty at the minute. I've recently left a place that didn't like things going on there too much, which is fine. So what I'll do, Josh, is I'll probably let you know when, it's probably going to be a couple of weeks, but I'll let you know when it's all up on GitHub, and hopefully the plaster bit's in there as well.
Awesome.
And then the important bit is there for me that I can then I either keep using it as a training tool, or the beauty is, as people say, well, I don't want Saki, I want invoke build. So, okay, because of Plaster, give people a choice. Which build system do you want, Saki or invoke build? Someone else can add that config file in and just switch them out. Another good thing about using something like that.
Awesome. Cool. Well, over to you, Mike.
I'll say good morning because it's 5:30 a.m. where I am right now. I know it's evening time for you guys, but thank you for having me. Let me get myself set up here. Ed, nice job. There's a lot to take in there.
Yeah, a bit too much, I think.
Nah, that's okay. All right, so let me get myself set up here. All right, let's... What's going on here? Sorry, guys, bear with me 1 second. There we go. All right, you should have some slides up, and then hopefully you guys still see a presenter view and not, you still see slides and not all my goofy notes. Can someone just let me know that that's what you can actually see?
Yep.
All right, beautiful. So
awesome.
I am probably going to do the exact opposite of what Ed just did. And I say that because this is a one-on-one talk. And because it's a one-on-one talk, there's not a lot of demo. So I have a ton of slides I want to get through with everybody, and I'm sorry to put people to sleep with slides, but let me explain why. So what I'm going to be talking about today is remoting 101 and how you can sell remoting to your InfoSec team, your C-suite execs, your managers, whoever it may be. And the reason that I did this talk is because basically I had this situation come up for me, and what I find when I talk with people is that a lot of people still seem to miss a lot of the pieces involved with PSRemoting and getting the basics set up in your environment. So rather than give you a bunch of demos, I've taken those demos and put them into slides so we can get them really quick. There's a lot of little pieces, super easy to configure. There's nothing here that's challenging for anybody. So rather than make you guys watch me mistype stuff in a demo, I've pre-configured most of the stuff already. So with that being said, for those of you across the globe who don't know who I am, my name is Mike Kanakos. I'm an AD engineer, and I like to call myself a PowerShell fanatic. I've done a lot of things in the community the last 2 years, and I like to write. You can find my stuff online, and if you're interested, hit me up on Twitter or send me an email. So my question to everybody on this call is, have you had this conversation in your organization yet? You know, it goes something like this, and this was the conversation that I basically had with my InfoSec pros at my company, my previous company, which was, hey, I'd like to enable remoting on our computers. To which I was told, are you crazy? And, you know, what are all these reasons why we couldn't do this? You know, what if we get owned? What if this? What if that? What could potentially happen? But the end result was not going to happen. We're not going to run WinRM and remoting on our network. And they basically said, we're not going to run it because we don't know how it works. And that's probably the right attitude to take. If you don't know how something works, you don't turn it on. But there's this fear that permeates with PowerShell remoting that, you know, I turn on remoting in my environment, and all of a sudden, somehow I've gone from being able to make a remote connection to exposing all my computers on the internet, and there's no way we're going to be able to protect ourselves. And that's not really the case. So that's really the focus of what we're going to be talking about today, is basically showing you how you can get remoting set up safely, correctly, and hopefully talk about this with your team members so that they understand how it works and how you can get this sold to your executives. So before we do that, let's talk about what the heck is happening in the world today with malware. So today, PowerShell is a very big tool in the use of getting malware onto machines. Less than half the attacks that are happening now are actually putting malware on the machines. They're just using malware to gather data, excuse me. So malware writers are using PowerShell as a dropper, or even more prevalent now is they are doing PowerShell to just simply steal data and leave. And it's easy because it's the same reasons that we like to use PowerShell. It's powerful. You can get a lot done very quickly, and you can get to very big parts of the network without a lot of work. And malware writers know this. People who are trying to steal data from us know this. And they can do their work, and they don't really have to leave a lot of tracks for them to be found. So it's a very convenient tool for them as it is for us. And as I just said, PowerShell is being used mostly as a downloader and for a way to move around the network. So, you know, what makes it worse is a lot of organizations are not enabling monitoring, and makes it very hard to find this stuff. So most attackers don't even have to cover their tracks. They can just work in plain sight because they know most people are not watching. So, you know, this is the stuff that makes InfoSec professionals worry at night. And, you know, executives think like, oh, there's no way that I can enable these tools. But the truth is, most of that is easily preventable with some easy configurations. So I would like to say that what we need to be working on is understanding the fear and the uncertainty that lives in most people's minds, and figure out how to solve that. Okay, so let's start with some basics. If you want to run remoting in your environment, you need to understand what runs on your network. That's just a basic requirement. Not only do you need to know what is running on your network, but you need to know how it runs. There's a lot of information about how this stuff works. Most of it is wrong. And a lot of the information that is being shared is just not going to help you. So I'd like to give you some information that'll make it useful for you and easy to do. I have two goals of this talk, which is one is hopefully you come away with one thing that you can use tomorrow. And a greater goal would be, I would like you to be able to talk confidently with your security team about how this process works. And the reason I say that is this: I don't have some magic bullet that's going to tell you how to get this enabled in your environment. I think the way to do that is so that you can talk intelligently about remoting. And when you can do that, I think your security teams will trust you because A, you can explain how it works. You can talk about the controls you're putting in place to make it safe. You can talk about how you can audit systems so that we know what's going on. And last, most importantly, we can talk about how we can shut down the systems if we need to, if there's a problem, and how to find information about if we think someone's been compromised. So when you put those things together, the magic piece here is that when you talk confidently to your InfoSec team, I think they'll be more supportive of wanting to run things in your environment when you can confidently say that you understand how they work. And the funny part about this is not everybody has this figured out yet. And I don't know if everybody's familiar with this screenshot that's on the screen, but this is a screenshot from an environment I have worked in. So if you're not sure what you're looking at here, that is a remote desktop connection manager window connected to a Server 2016 core system. What's the point of remoting into a system via RDP that has remoting set up and ready to be used, and it's only a command line system? So my point here is that the reason we need to talk about this remoting one-on-one stuff is a lot of people just don't get how it works. Yeah, you could RDP into a system that's console only and then run console commands locally, but that's kind of defeats the point. So let's go through this, let's show how it works, and let's get you guys some information. So here's what we're going to talk about today. I am going to go back to the foundational knowledge. We're going to talk about remoting. What is remoting? Is it safe? How does it work? All the authentication, what protocols are used, how you can turn it on, how you can control access, and there's one bullet item here that says logging, but probably that's the most important part of this whole talk. So with that, let's jump right into it. I want to tell you that a lot of the stuff in the beginning is simple choices. It's either on or off. But when we get farther into the talk, you're going to get to a point where you can make choices about how you can customize things for your own environment. So in the beginning, the choices are binary. It's on, it's off. It's yes, it's no. As we get farther along, well, you're going to have to make some decisions. Do I want to allow it on all machines? Do I allow it on some machines? Do I want to create some groups to control access? We're going to go through this step by step so that it doesn't seem overwhelming. So super duper basics here. What is remoting? Remoting is a way to run commands on remote systems securely. And it's the securely part that we really need to focus on, because there's plenty of ways for us to access remote systems. How can we do it in a safe and effective way? So the basics of remoting is that it runs on top of the Windows Remote Management Service, WinRM. WinRM uses the WSMan protocol to make authenticated and encrypted connections every time without a doubt. That is the only time that you can make that statement if you're if you're connecting to machines in Windows. Those authenticated and encrypted does not always happen with things like RDP, WMI, simple command prompt. The only way that you can guarantee authentication and encryption and secure connections is using PowerShell remoting. So because of that, we shouldn't be fearing remoting. We should be welcoming remoting, and we should be forcing more people onto that, because when we are on remoting, we can control what people do. We can log what they do. We can make sure that what they do is not being sent in the clear, and we can make sure that everything that they're doing is something we want them to do. So guys, I might need a little help here because I can't see the chat in the view that I'm in. So if someone is going to ask a question, I'm going to miss it. So maybe someone could just keep an eye on chat. And if someone has a question about anything I'm doing, maybe just break in and let me know, because I heard some prompts there, but I'm not sure if there was questions.
Yeah. I'll flag you if anything comes up, Mike.
All right. So round this up really quickly. The web services for management protocol, WSMan, is what Windows Remote Management, Windows Remote Management, WinRM, uses to make connections. WSMan is an open standard that Microsoft has adopted and heavily influenced, and that's how data goes back and forth. Keep in mind, I said web services. We're going to talk about that more in the future. All right, so is remoting safe? That's what most people want to know. I'm telling you it is safe, but you can't take my word for it. You have to be asking why. So when we ask why, the reasons why is remoting is going to give us four things: authentication, encryption, logging, and control. Okay, the control piece is the one that I can't talk about today, because if this is a one-on-one talk, the control piece is the 201, the 301, and the 401 add on to this talk. And let me explain that a little bit. So what we're going to talk about is how to set up connections, how to secure connections, how to limit connections, how to log connections. You can take it to the next step and you can say, well, when someone connects to a machine, even though they have admin access, I want to say you can only run these 5 commands. That's the control piece. It's called constrained delegation, also known as JIA, just enough administration. And the idea is that just because someone is an admin doesn't mean that they need to be able to run every single command via a remote command prompt. You may want to say that my desktop admins, they may have admin access to a machine, but for some reason, I'll just make it up. I don't want them to be able to set the IP on a machine or change the IP on a machine. You can do that through just enough administration by tailoring what commands certain groups of people or certain users can do. We're not going to talk about that today because that is a whole separate topic unto itself. So let's get through to the basic stuff, Okay, just remember it's these 4 areas here that deem why remoting is safe. If you can understand these 4 concepts, you'll be far ahead of most people. So I'm going to show you a quick demo here. This will be the only demo I'm going to show. And what I'm going to do here is, just in case someone has never seen how a remote connection works. Now, I have a lab environment, but it's not working right now, so I'm simply going to make a remote connection to another machine in my house. So I'm simply going to show you how I'm going to make some connections, and we can go on. So I got to do some setup here to make this work. So the first thing I'm going to do is I'm going to grab some information from my machine, which I'm going to show you in a second. I'm going to authenticate. All right, I'm going to authenticate to the other machine.
Hey, Mike.
Yeah.
We're still seeing the PowerPoint.
Ah, that's no fun. All right, let's fix that. You know why? I just shared out the application. So let me stop this and then I'll share out my screen. All right, so let's start over again here. All right, so we're going to set up some information. I got to grab some information. I'm just going out and getting some information from my machine so I can show you guys some stuff later on. I'm going to authenticate here. All right, I'm going to save that to a variable here. All right, so I'm going to make sure the wife's machine is on. Do a test connection. Should come back in here in a second. Okay, this is basically saying that my wife's machine is on. Here's her destination IP, 189. All right, now in this demo here, I am not in a domain. So I have a little bit of a weird work group setup where I have to connect to another machine in order to make it work. So I'm going to do some sim session setups here to work. This isn't important. I just want to show you how we can make a connection. So I'm going to instantiate a session to her machine. All right, so now real simple. So this is my machine. This is her machine. All right, it's very simple now. If I wanted to, there's 3 ways that you can make a remote connection to another machine. You can invoke command, you can enter PS session, or you can use the sim commandlets. If you use anything other than those 3 scenarios, you're not doing remoting. So in this case, I'm going to do an invoke command, and I'm going to say invoke command to the computer. I'm going by IP address. I'm going to use those credentials that I put in there before. And then I'm going to run a script block, and it's just going to return the host name of the machine. All right, so this is her PC name. All right, so invoke command is how you pull information from a machine remotely and bring it back to you. Another way that you could do that is through an interactive console session, enter PS session. And this is the same thing, except now I'm sitting at an interactive console prompt here. This shows that I'm connected to her machine, and this is my location on that machine. And when I get there, you can see I can perform the same thing, and I get the same result back as I did up here. And just to show you who I am logged in on that machine as the account that I authenticated at before. Super simple stuff. And while I'm at it, I want to show something for later on. I'm going to log in with a different user here. This is just to illustrate a point. This will, PS session, that's what I wanted to do. Let's do that. All right, let's try this again. Also wanted to illustrate something here that a lot of people don't know, that you know, when you input passwords into PowerShell, that information is saved, and that information can be reverse engineered pretty easily. So we're going to talk about that a little later, but to show you that here, I have logged in and I've saved my credentials to a variable called credhack. And if I was to return that, you would say, oh, I can't see the password. Well, that's actually not true. It's very simple. It's saved in plain text. I just wanted to point this out to people. We'll talk about this a little later. You see, there's my super secure password. So it's very easy to get this information. This is why we need to make sure we understand what we're doing with systems and understand how we're safeguarding data. So we'll talk about that a little bit later. I'm going to jump back into slides here, but I hope this illustrates it's super simple to make a remote connection. Once you have the authentication set up in a domain, it's even easier, which I'm gonna talk about in just a second. But you can connect in a workgroup scenario, you can connect in a domain scenario. Super simple stuff. All right, so let's go back to our slides here real quick. And while I'm getting set up, if anybody has any questions, feel free to ping me with them, and I'd be happy to answer any questions you have. While we're doing that, we're going to get to the meat and potatoes of the stuff that you guys are probably interested in seeing now. We should be, hold on 1 second, guys. All right, I'm in my presenter mode. I hope you guys just see regular slides. We good?
Yeah, we're good.
All right. All right, so I gave you some information about remoting, and it's been a lot of boring stuff so far. Let's get into the stuff that really matters. All right, what is remoting? Okay, we talked about a way to securely connect to other machines, but the thing that we need to understand here is remoting is not the security piece that people think it is. Remoting is really the road to get you to where you want to go. I like to explain it as it's the road between two houses. You want to go visit your friend, you go on the road, you get to his house, you knock on the door, he sees if it's you. If you are the person that he expected, he lets you into the house. I know it's a super simple example, but it's supposed to illustrate the point. The road was not the security measure here. It's what happened when you got there. And that's what's important here, because remoting takes the hit as being this security like wasteland. Oh my God, I turned on remoting. I'm going to be in such bad shape. It's not remoting. It's your end nodes that control the security. So in this example here, let's make a fictitious network. We have a bunch of machines on a network that connected via Ethernet. These green locks, they represent security. Okay, in this case, we're going to talk, and we're going to say security super tight, super locked down. Nobody can connect to anybody's machine. Okay, that's a great environment. Awesome, except in this case, nobody can even make a connection. All right, what happens if we took that idea and we reversed it? If we took away all the security and we said, there's none now. We're going to allow anybody to connect to any machine. You go to a machine, you come right on in. What has changed in this example? Did we change anything with remoting? Did we change anything with the path? Did we change anything with the way you got there? No, we didn't. We only changed the security on the end nodes. And that's probably this slide and the next slide are probably the most important things for you to understand if you want to understand how remoting works. If you want to secure your network and you want to turn on remoting, you need to understand the security of your end nodes that people are going to connect to. Because when they get to that end node, what's going to happen, and I'm going to detail in a second here, remoting is going to say, hey, who are you? And what is your group membership? Because this is going to work in a domain environment. So we're aware of all our AD groups. And when we look up our group membership, if everybody is a local admin on every machine, you have no security. So the takeaway here is if you work in an environment where you have 35 domain administrators for 50 employees, you don't have any security. If every help desk tech is a local admin on every machine, you have no security. If every user is a local admin of their machine because you couldn't figure out to make an application work, again, you have no security. You cannot blame PowerShell remoting if you get owned through a phish attack or something like that, and now that attacker can go anywhere they want in the network. It's not remoting's fault. It's because we have a lack of security on our end nodes that allowed our attacker to go anywhere they want in our network. But the problem is everybody thinks that's remoting's fault, and it's unfairly so. So let's talk about how that works and how you can change that. All right. So if you want to make a remote connection, it's a 4-step process. It's very simple. It's not the only 4 steps involved. However, it's the 4 steps that you need to know. Let's talk about them. So every session on a machine is authenticated. Now you may not realize that because you just fire up a PowerShell command prompt on your machine, and you never got authenticated. You never got prompted for credentials. But when you logged into your machine in the morning, Control-Alt-Delete, you logged in. The computer knows who you are. When you run those sessions, they're running as you. If you decide to run PowerShell as an alternate user, run as, or use the credential parameter, PowerShell knows you're running as a different user. The point being is that every time you run a session, PowerShell is aware of who is running that session and on what machine. When you want to make a remote connection, you're going to leverage one of 3 types of commandlets I mentioned earlier. Enter PS session is that interactive command prompt. If you want to send information to a bunch of machines and pull it back without having an interactive command prompt, that's invoke command. Or any of the sim commandlets. Anytime you hit those 3 things there, that's remoting. And when you do that, what you're going to do is you're going to create a session to a remote machine. So in this example here, we have, this is our local machine, and this is a remote machine we're going to try to connect to. And what's going to happen is when we use one of these commandlets here to make a connection to the other machine, we're going to instantiate a session. This is not a VPN tunnel. It may look like it on the diagram, but this is just a session with another machine. But this session, once authenticated, is encrypted, and it runs over just 2 ports. And remember I said web services earlier. We're using HTTP or HTTPS to do all our work. But because our connection is encrypted, the data that's going back and forth here is completely safe. It cannot be read by someone who's just on the wire trying to steal commands. So what ends up happening is you're going to type commands on your machine. When you type those commands, they're sent over to the remote system. The remote system is going to process those commands, and it's going to send the results back to your machine. So when you have a remote session, the remote session is where the work is being done. You're just passing information back and forth. The remote session executes that work and gives you the results that you want to see. And this is how it works, whether you have 1 remote connection or 100 remote connections. PowerShell uses something called run spaces behind the scenes to map out those connections for us and do all the work. So all you need to do is enter PS session, computer name. It's going to pick up your credentials automatically, and it's going to make a session for you. If you have rights, it's going to make that session, and it's all done behind the scenes. So let's dive a little bit more into that. So we talked about authentication. Let's go a little bit deeper into that talk. Remoting is designed to work hand in hand with Active Directory. And because of that tight bond with Active Directory, we get a lot of security built in. And not only do we get a lot of built-in security, but we get a lot of stuff done for us without us even having to do any work. So when you authenticate to a remote system, it's going to look up your group membership on the remote system, and it's going to figure out what group membership you have. And it's going to do that via Kerberos, standard AD stuff. This is stuff that should not scare any InfoSec team at all, because you're doing it all day long wherever you go in and hit shares, log into systems, RDP to machines. It's the same exact process. Now, if you have a work group network, which hopefully nobody does, but maybe you're an MSP and you have to support other businesses and you're not on their domain, you can still do all this like I did at my home network, but now you're going to fall back to NTLM, which is not exactly the most secure method of authentication, but it is still authentication built in. And when you get over to that other machine, what access you have is going to be controlled by two groups. Everybody, I think, understands administrators, right? I'm an admin. I get to do everything I want on that machine. But there's another group called remote management users that a lot of people don't know what it's used for. If you read the description, it'll say right here, members of this group can access WMI resources over management protocols, WSMan, Windows remote management. So this is clearly used for PSRemoting. So this remote managers user group is used when you want to give people non-admin access, because remoting is designed for admins. It's not for Joe in accounting and Mary in marketing. They don't need to remote to other machines. This is for admins to remote to machines to do administrative work, configure systems, troubleshoot. So we assume by default that those people are going to need to be administrators. So when you don't need to be an administrator and you need to give temporary access or limited access to someone, that's what remote manager users are. And this is going to be people that live in this. This is the same thing as remote desktop users in theory. You remote into a machine. If you're in the admin group, you're automatically granted RDP access. If you're not in the admin group, you need to be in the remote desktop users group in order to gain access to the machine. But then when you gain access via RDP, you have limited access. And it's the same thing here. People that are in this group, they're going to be able to do the get commands, the things that query information. They're not going to be able to run sets. They're not going to be able to do the commands that start with a new or things like delete or remove. So this is a way that you can give people an ability to query information on a machine, but not be able to make changes on a machine. All right, so in that last slide I just showed you, right here it said can access WMI resources, okay? If you've been paying attention, you may have picked up that when I said earlier there's three commandlets or three groups of commandlets that do things, I mentioned the SIM commandlets. And now over here it's saying WMI. So I want to talk about what is the difference between SIM and WMI. And I can't see the chat here, so I'll take a just brief moment, see if anybody has a question. But I'm curious, does anybody actually know the difference between SIM and WMI? If you think you know, throw it in the chat. I'll talk about it in about 10 seconds here.
Isn't it Microsoft's version versus industry standard?
Bingo! That is almost 100% correct. However, there's a little flavor there to add on top of that. So SIM and WMI are essentially the same thing. So if they're the same thing, why is WMI bad and why is SIM good? That's really what we want to talk about here. So the important part is that WMI, as the person just said, is Microsoft's version of an open standard called Common Information Model, SIM. Okay, so where are we going with this? I'll explain. This will make sense. When SIM was created, this is an information management protocol many years ago. This has been in place on all computers for a very long time. It's a way to programmatically access data on a machine. There was no built-in standard or specification for networking. So Microsoft bolted on what they knew, what they had already. Whoops. I'm sorry, guys. Yeah. Okay. Microsoft used what they already had in their bag of tricks, which is DCOM and RPC, as a way to put remoting onto SIM. That's what WMI is. It's SIM plus DCOM and RPC. They called it WMI, which a lot of us know. Although, WMI gets a bad rap because it's not exactly firewall friendly. It uses some well-known ports. It needs dynamic ports. Nobody wants to poke holes in the firewall with these well-known ports that are used for other things. So nobody really wants to use WMI for remoting. Microsoft knows this, and in 2012, they came out with a new version of WMI. But I can't make this stuff up. It's true. They did not give it a unique name. So people started calling this new version SIM. It uses WSMan instead of DCOM and RPC. And then I just said, people started calling it SIM or what we know of as WinRM. Well, the name stuck. So what's the difference between SIM and WMI? Really, there's nothing. The protocol that is used to transfer data to and from machines is the only difference. Otherwise, they're essentially the same. Now, Microsoft isn't exactly, they play nice all the time. So when they pushed for WMI, and there was nothing else to use for a long time. So this is how we got ourselves into this situation. But I could show you this very simply. Here is an example of using get WMI versus get SIM instance. Now I'm doing this on a local machine. I'm not doing it remotely. But you see the exact same data comes back no matter what command you use, because I'm accessing the same information stores on the machine. So it would make sense that the information that comes back is exactly the same. The difference would be here if I did this remotely. If I did this remotely and I did get WMI, I'm going to use a whole different protocol to go access that machine, pull the data back. If I use get SIM instance, I'm going to be using WSMan. But when I get to the machine and I ask for the information, after I get there and after I'm authenticated, I'm grabbing the same information. So I want you to understand, SIM, WMI, they're essentially the same. One uses really crappy protocols for remoting. One uses really great protocols for remoting. That is why you hear people say you got to get off of WMI and you got to get onto WinRM and using SIM, because you're accessing the data in just a much more elegant and safer way than you were in the past. So let's sum this up real quick. SIM, it's firewall friendly. Earlier in the presentation, I told you it uses 5985 and 5986. Those are web protocols, web ports, HTTP and HTTPS. Authentication is done automatically in our network via Kerberos. And this is all being done through the WSMan protocol, which WinRM leverages to run on our machines. WMI, sort of the same, but different. Not very firewall friendly. You got to use 135, 445. Also going to have dynamically assigned ports, DCOM and RPC, which nobody wants to use. So that's the difference between the two. This is probably the most confusing thing for everybody to talk about with remoting. So if you can pick this up and how the remoting conversation that I showed earlier works, you're going to be far ahead of most people. All right, so how the heck do you enable remoting? It's super simple, and this is why I did screenshots, because this stuff is like bang, 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 move on to the next thing. You have two methods of enabling remoting. From an administrative command prompt, you can run WinRM quick config, or from a PowerShell command prompt, you can type enable PSRemoting. What's the difference? Well, in the first example, WinRM quick config is going to bring back the current state of the machine and then ask you if you want to turn on remoting. So in this example here, it's going to say, yep, remoting's not on. Do you want to turn it on? Sure. In the second one, you're saying enable. It's assuming you want to turn it on. It doesn't tell you the current state. It just does it. The end result of both of these commands is exactly the same. It's going to turn on remoting, and it's going to turn on all the ancillary pieces that need to be associated with this to make it to work. However, there's only one problem. If you work in a big environment, you are not going to do that by hand. You're going to use another method. And if we're talking about Windows PCs, that's going to be group policy. If you want to do this in group policy, that previous command that you just saw has 3 steps in group policy. We're going to turn on the WinRM service. We need to set it to start. And then we need to poke a hole through those client firewalls that I know you guys are all using on your machines. So I'll stop there for a brief second and see if anybody has any questions before I jump into how we configure this real quick. So there was a little bit of a passive aggressive joke there. I understand a lot of people are not using client firewalls, but you're going to see very quickly here that if you are using client firewalls, you can change the level of security on your environment tenfold very quickly and very easily. So I would like to say, if you're not using client firewalls on your machines, I get it, but you should think about it. and you should start thinking about how you can use it. All right, so how do we set this up? Very simple stuff. If you are familiar with group policy at all, this is a no-brainer for you. So step one, we need to enable PSRemoting. All right, we're going to turn on the remote server management through WinRM. Okay, we're going to say enabled. Very simple. There's an option for IP filtering. I am going to discuss that in about 5 slides. We're going to come back to that. But I told you binary choices, on or off. Not much to do here. I set that, and there I go. I'm off to the next one. I need to set the Windows Remote Management Service to auto start. I find the service. Here's the path. I set it to automatic. Another easy one to do. I haven't even discussed PowerShell. I mean, our group policy. You can do this at the domain level, OU level. You can apply it to groups, individual machines, groups of users. Lots of choices here. I'm assuming everybody's got that part down, so we can move on from that. Okay, third piece, I need to poke a hole in the client firewall. Another really simple thing to do because Windows has built us a predefined rule. All you have to do is select the rule and apply it. The settings can be found at this location here. So now I hope you guys understand why I didn't do a bunch of demos, because it's so much faster to do this than watch me do a bunch of typos. All right, so let's talk about those groups again. Administrators, remote management users. I said earlier that you're not going to want to configure remoting at the command line for bulk machines. You're probably going to do the same thing with your group management the same way. You're probably not going to configure groups on local machines if you have 1,000 machines to configure. You're probably going to do that through a group policy. Remember, remote management users is going to be equivalent to read access on a client, and you're going to do that through group GPO. You can do that super simple, and you can do it super fast, and it can be very effective. I'd like to give you a little example how that works. So if you want to populate the remote management users groups on a machine, it's really simple. You can jump into group policy, computer config, policies, security settings. There's going to be restricted groups. Restricted groups are basically the built-in groups that are on everybody's machine. And I mentioned earlier that remote management users is on every machine. So this is a group that you can leverage to group policy. So this screenshot here is a little bit confusing, so I want to explain it. The top box is somebody has created an AD group called PowerShell Remoting. The domain happens to be called R2, which is a super crappy name, but that's the name of the domain. This bottom box is the group that they want to add the top group to. So I want to add the PowerShell Remoting group to the remote managers users on all machines. Again, you can apply this at the domain level, at an OU level, per group. So if you've been following along and you understand what I'm talking about, if you want to give read access to people very quickly, I'll just say help desk users. If I want to give my help desk staff read access to all my machines in my environment super quickly, I do those 3 settings that I showed you earlier on how to turn on WinRM. That can be done in about 5 minutes. I create a group in AD and I assign it to this remote managers users group. And if I'm feeling bold, I can say for all machines, I drop my users in this group. And like that, I've now configured remote access for all my help desk staff to be able to remotely read information via the command line securely using PSRemoting. Obviously, there's a lot of choices about how you can skinny that down. We'll talk about some of that. Remember, I said earlier, IP filtering. IP filtering is such an amazing option that you can use if you're using client firewalls. And I want to explain it because remoting is meant to be on or off. And I told you that remoting is not the security boundary. It's what happens when you get there. Your group membership is figured out when you get to the remote node. And if you have access, then you are granted access. However, If we use the firewall to say, nope, I'm not going to allow that connection, well, now I can use that to my advantage, and I can turn off the ability for a lot of machines to not even be able to accept a connection. So when you use IP filtering in combination with remoting, you can super customize your environment. I'll give you an example. Let's say you have a 500 computer network, and let's say you have 30 admins in your environment. Now that could be domain admins, help desk staff, app developers, whatever it is. Just keep it simple. You could make the simple connection in your head that only 30 people out of 500 need to make and start remote connections. Do my accounting users need to remote to another machine? Probably not. Marketing? Nope. How about any of the admin staff that helps out our execs? Nope. How about the facilities people? Nope. The people that need to use remoting are your administrators. So with that in mind, if I know that, I can use it to my advantage. I'll show you how. Let's say all 30 of my admins are on an administrative VLAN, 10.10.5. I put all my admins on 10.10.5.x. I can configure here, hey, for remoting, I only want to allow connections from 10.10.5. So what did I just do? I can turn on remoting in my entire environment, but because of my client firewall, I can say, I can only accept a connection from my 30 admin machines. I've just shut off remoting for 470 machines. Very simply. So an attacker pops a machine through a phishing attack and gets Mary's credentials and is on Mary's machine. Now Mary wants to, now he's taken over Mary's ID and he's going to try to remote to Bob's PC. Can he do it? No. But he's got the credentials. Oops, can't do it. Firewall is going to stop that connection because that's not an allowed IP to make a connection from. So a couple other ways you can use this. Maybe you don't have all your admins on an administrative VLAN. Well, if you really want to, you could put manual IP, static IPs in the list, and it can get a little gross, but you can do that. But another option that you can consider is jump boxes. You can make jump boxes and you can say those jump boxes have, 10, 10, 10.1, .10, .11, .12, .13, .14. I have 4 jump boxes. And I only want to allow connections from those 4 jump boxes. So now my admins, they remote in to those jump boxes and they do their remoting from there. So now I have 4 machines in my environment of 500 that are allowed to initiate a PowerShell remote session. So now think about selling this to your InfoSec team. Think about encryption, authentication, talk about limiting connections to the IP firewall. We haven't even gotten to logging yet. When you know that these options exist, it makes it so simple to sit down with those executives, that InfoSec team, and be able to say, look what we can do with this tool to help us get our job done, but protect our users from bad people. So if you haven't considered IP filtering, oh my God, this is such a powerful tool for that you can use. That's why I said if you're not using client firewalls, you can turn up the security by 10x by trying to figure out how you can institute that. I know it's hard to do, but that's the way you really want to be looking. Now, what happens if you're not in a domain? There's this concept of trusted hosts. When I connected to my wife's machine about 20 minutes ago, that was doing it via trusted hosts. It's garbage. It's totally different than a domain setup. Domain says everybody trusts each other because we have that authentication built in with Kerberos. When you have a trusted setup, workgroup machines with no way to authenticate people, they've built in this thing called trusted hosts, and it works completely opposite of what you would expect to see. You put in the list of machines that you trust you want to connect to. And when they get to the other side, they are authenticated. And if there's an account on the other side, they're allowed in. This is really, no one's really going to use this unless you're doing work with computers, but I just wanted to show you that it's there. So in this example, trusted hosts, I'm looking up, this is how I set the trusted hosts on PC01. If I do a get, it now shows me that I've added this one to my trusted host list. If I want to remove it, it's a clear item. And if I do that again, it shows me there's no values there. All right, so I'm going to go through a quick summary here because this is basically part one. And I know I've taken a ton of time already, but we're going to fly through the next stuff. Enabling PSRemoting, it's 5 pieces. You enable the service. You set it to auto start. You configure your firewall exceptions. You decide who gets access. You decide what connections can be initiated from. And then you decide how you want to configure those 4 options. It's going to be GPO for most people. I'll take a quick pause here. Does everybody understand what we talked about so far? Does anybody have any questions? All right, let's keep going. What else? I've talked almost exclusively about authenticating users. I told you there was 2 ports that are used, 5985 and 5986. That 86 port is used when you start using certificates. You can authenticate users and computers when you do certificates. That is really a great option. It's not easy to set up if you don't have certificate store set up in your environment. Not even going to touch it today. I also mentioned earlier, GIA. It's a way to constrain what commands can be run on a remote system once you make a connection. Joe's an admin. Joe connects to a remote machine. Nope. I'm saying when you connect to this machine, Joe, I'm going to let you in 4 commands. That's GIA. GIA is awesome. I don't have time to talk about that today. SSL and certificates allow remoting, that 5986, which I just talked about. And then now we're going to talk about logging. And I'll go through this quick. But logging is crucial because when someone gets compromised, you need to figure out what happened. And the only way you can do that is to turn on logging beforehand. Logging consists of 3 pieces. There's one called module logging, script block logging, and transcription. Now, everything up to this point, with the exception of IP filtering, was on off. You either turn it on, you turn it off. There's not much to choose. IP filtering, I showed you how you can start to dictate things in your environment and can control connections. Logging is completely up to you. There is no right or wrong here. And you're probably going to turn on a combination of all 3 if you really want to do it the right way. But I can't tell you what's the right thing to do. I can make some recommendations, but what ultimately is the right thing to do is going to be based on your environment and what makes the people in your organization feel safe. So the first one we're going to talk about is module logging. And what module logging does is it grabs all the activity related to a specific module, hence the name module logging. So if I want to grab all the activity related to the Active Directory module, I would turn on module logging, and when I turn it on, I would specify the name of the module that I want to log, and it'll grab all that information. Events are written to the PowerShell log. All these logging options will blow up your logs. So if you're not comfortable assigning 1, 2, 3, or 4 gigs of disk space, you need to get to that point, because these logs are going to fill up and they're going to roll over. And if they roll over, it's essentially useless. If you turn on logging and you can't go back and see what you've done in the past, there is no point in having logging to start. The 3 options for logging are all contained in the same part of group policy. Group policy is really the way that you want to do this. There is no other way. It's the easiest way. You could do some local group policy, but honestly, domain-based group policies are your friend here. So I mentioned logging, module logging. It's on or off, right? Then we're going to talk about PowerShell script logging, same spot, transcription. They're all here, okay? When you turn on module logging, you're going to get, you know, when you configure that, you can turn it on and you configure the module that you want to log. When you click the show button, you can pick the module that you'd like to log. And when you do that, that's going to start to produce some results. You'll get information in your logs that'll tell you exactly what happened when a connection was made. So here I told you I turned on logging for the SMB share. So in my log, I get an entry here that says someone tried to run get SMB share. Here it is who ran it. Here's the command they run. Here's information about the machine, and our standard logging stuff comes up down here. That's module logging. It's very simple to set up. It's super noisy. It's really noisy. It's going to capture a lot of information, especially for some of the bigger modules like Active Directory or Exchange. Those modules have tons of commands, and there's a lot of stuff that's using those things, so you're going to get a lot of logging that's put in there. The other option you have is script block logging. So if you remember, I talked about earlier, invoke command, computer name, script block. Script block contains the information that I want to run. That stuff gets logged in this script block logging. It records blocks of code as they're executed, written to the event log. And what you may not know is this is on automatically in your environment today. Microsoft has found this feature to be so useful that it's turned on by default. So if it's turned on by default, why am I sitting here telling you that you need to turn it on? Well, that's because Microsoft has turned on a subset of script block logging. So what Microsoft has done is they've figured out that when a lot of malware attacks are happening and phish attempts and stuff like that, attackers are trying to run things differently than you and I. They're taking steps to try to hide their code. So they're calling that out. When they see that behavior, they automatically log it. And that's put into these script block logs. So you can go look at your machines right now and you can look for this stuff and you can tell if there's weird activity happening in your machines and you haven't even configured anything yet. This produces a lot of logs, not as much as module logging, but again, you got to be up there in the log sizes, a gig or 2 gigs. Turn it on the same exact spot, right? We're going to turn this guy on here now. Very simple. I'm going to turn on or turn off. Not a lot of choices here. However, there is this piece here. And this piece, I would say, should have been in a default option. You have a choice here to decide if you want to turn on invocation of start stop. And what that means is if you fire up a PowerShell remote session on your machine, you could have that session open for hours or days. If you're running commands against the machine and those commands are lengthy, Microsoft is going to break out those entries into various log entries because there's a limit how much each log entry can hold. Okay, that makes sense. How do you know when a session starts and stops? The only way to do that is by checking this off. Otherwise, when you go to put those events back together, you're never going to be able to figure out when that session was initiated or when that session ended. And if you're trying to figure out what someone is doing, you're going to want to know when they attempted to make a connection and when that connection was severed. So I would say that if you're going to turn on script block logging, you should just turn this on. All right. So same thing here. We turn this on, and this is going to grab blocks of scripts, blocks of code, regardless of what it is. So that's basically, think of this as saying everything. Okay. So I put the entry in here. Someone runs get Windows feature, and it tells me that this was run from a script. And here's the path where it was run from. Okay. I can see here. Oh, I should say this stuff is written to the PowerShell operational log, and you can see here who ran it, times, computers, all that good stuff. Script block logging, module logging are the two ways that you can log information through the event log. There's this third option called transcription, which is sort of a red-headed stepchild to logging that you may not understand very well. If anybody has ever used start transcript and stop transcript, you've used transcription. Turning this on is basically saying every time I initiate a session, I want to do a start transcript and a stop transcript, whether the person turns it on or not themselves. So the interesting thing about this is I started off by saying the two other options are going to throw stuff in the event logs. Well, I've kind of been preaching that you need big event logs. What happens if you don't have big event logs? What happens if you don't have a SIM to gather those events and pull them off and store them somewhere? You're kind of at a disadvantage. If you don't have that, transcription may be an option for you. Now, I'm going to tell you that transcription is pretty scary because it writes everything to text files. And you're probably thinking, why the heck do I want to write stuff to text files? Well, remember, if you don't have event logging set up the way you want, this is really your only other option. Now, maybe there's third-party tools that do a better job of this stuff, but the built-in stuff, it's either to the event log or to text files. And I'll tell you why you may want to use this. If you don't have the event log set up in a way that's going to work for you in bulk, this is a super simple way for you to grab all activity on all machines all the time. And then you sweep them off and you put them somewhere else in a secure location. But if you remember earlier, I showed you that credential hack. Passwords are saved in the clear. You just have to know how to get the information back. If you're using PSRemoting, those passwords that you're typing in there, they can be retrieved. If you're writing them in transcription, you're basically putting any information that you're putting into a remote prompt into a permanent file. That means session keys, IDs, passwords, authentication strings, SSH keys, whatever it is that you're doing. If you're typing in a command prompt, it's going to be saved to a text file. So you really want to think this through and make sure you understand what you're doing. The way that you're most likely going to use this, if you want to use this, is you're going to turn this on and you're going to write information to logs. And then you're going to write those logs to a local folder on the machine. And then you're going to create a scheduled task that would sweep the logs off to a share. And you can create a directory where people can only write to on their machine. They can't open it up to read from. You do the same thing on the server. You make basically a Dropbox where the files can get dropped off, but the people can't browse the share to see what's in there. This now gives you a central archive of all the activity in your environment on a share. They're text files, so you can write a little code, to zip them up every day, and that will take those text files and they'll shrink them down to nothing. And then you can even go one step further and you can take those zip files and you can move them off to another resource. Maybe it's to backup. Maybe it's to a SIM. Maybe it's to some permanent archive. Maybe it's to a security server. The point is, there is a way to do this and do it safely. You just really need to think it through. If you'd like to do this, same thing. We're going into our logs. I showed you the locations before. You turn it on. You write where people, you pick the location where people are going to write to. Okay. I wouldn't use the profile directory. I wrote to C Windows PowerShell transcription logs. That doesn't exist today. You have to make that. That's what we did. We wrote them there and then we swept the logs off to a central location. Did we use this that much? No. It's not something you're going to use every day. It's when you have a problem to be able to go back and see what's there. Now, I will say, when you turn on logging, you have no idea how much information is being generated via PowerShell. Because if you have SCCM in your environment, most of that work is being done behind the scenes with PowerShell commands. Exchange, PowerShell commands. Anybody doing any AD stuff like configuration, there's going to be a lot of PowerShell going on. So whether it's the user or the computer that's running PowerShell, it's all going to get captured to logs. So when you need this, it's the needle in the haystack situation that you're going to be dealing with. But it's better to have it than not have anything. Transcription logging looks like this. It'll show a log. It'll say when it started, the start time, who ran it, who they ran as. You get your machine name here, all the information about the machine. And down here, you're going to see exactly what they saw in their command prompt. I run get SMB share. I get a printout exactly what they did, captured exactly to the log. It's that simple. Every time a session is started, you'll get one of these guys. When the session is stopped, this one will be closed and a new one will be started. In summary, there's 3 different log options, 2 write to the event logs, 1 produces text files. You need to know that all these options are going to blow up your logs or blow up a share on your machine. You need to increase log sizes and you need to be prepared to sweep those logs off to a secure location. I can't tell you what is the right combination for you. You have to figure that out. I would say script block logging is the way to go. Start there and then move on to the others. It's the easiest one to get going and it's just going to capture everything. It's going to write to your event logs. So let's wrap this all up. I've been talking for 1 hour and you guys are probably tired of hearing from me. How secure remoting is depends on your security posture at the end nodes. If you don't know anything else from this talk, you need to know that if you don't have any security at your end nodes, you should not be turning on remoting. Remoting is using secure protocols and an AD authentication. It can easily be configured from group policy. You can capture nearly every PowerShell command typed into a command prompt from any PC, but if you choose to do so. Choosing so has an impact. Think about that. There is no one size fits all for remoting and logging. You really need to think it through. Turning on remoting is on off. After that, you need to start thinking about where people can connect from, what kind of rights they get when they make a connection, and how much information I want to capture in their machines. But I hope more than anything, you understand that remoting is safe and you should be turning it on. And if that is a challenge in your environment, everything in this talk is what you need to be talking about with your InfoSec team so that they come away feeling the same way that hopefully you feel right now. With that, I'm going to shut up and I'm going to say thank you guys for your time. I hope it's not too late. I am happy to answer any questions you have. If you don't, I will say good night and I will see you soon. With that, I'll open it up for any questions you might have.
That was awesome. Thanks, Mike.
I hope it wasn't too much.
No, that was really good.
All right, so hopefully everybody's still awake. Hey, Shane, how are you? Mr. Brett. I'm glad you guys appreciate it.
Some familiar names.
Yes, yeah. So listen, I have to say something to you guys. I hope you didn't mind like 1,000 slides. I felt very guilty about doing slides. I've done this presentation before and I got beat up. I could show you guys. When I did my presentation the first time, I did it for James Petty's PowerShell Saturday. Why is this not working? I actually put a slide in my slides to say I got a ton of slides because they would beat me up so bad before the presentation that I was the only guy who did slides. But I can't figure out a way to do this presentation fast with a lot of demos. So this is not what I wanted to share. But so I hope it wasn't overkill. It's something I'm really worried about. I hope it was useful. Let's try that. And John, you're exactly right. There's so much information to digest. But if I could be honest with you guys, most people get it wrong. Just because there's a lot of little pieces and there's a lot of things that people assume, oh, come on, what is going on with this thing? So Brett, I can't believe it's early for you. Well, no, it's late for you again, right? No, it's the middle of the day for Brett.
Yeah, must be about lunchtime for him.
Yeah. Yeah, I only talk to Brett at like midnight for him.
Yeah, it's about lunchtime. I'm skiving.
I have to take a shower and get ready to go to work now. So anything I can answer for you guys? I know I threw a lot at you there, but if there's something, let's see. Hey, Charbs, remoting also past the hash, which is something for a sec. Yeah, that is true. There is a double hop thing that comes into play here. Why can't I get out of presenting? What happened here? I'm still presenting, right?
Yes. Looks like it's doing the like it's sharing the slideshow, so like we can click around it and
well, feel free. I can't. I don't even know how to get out of it. Let's see here.
But yeah, so I had a similar I had a realization today that I have an upcoming talk that I was really hoping to do live demos in. Did a practice run at work and realized I can't do them live.
So I really wanted to do this talk for the summit, but oh man, I am in some loop here. That's weird. But I kind of feel the same way. I don't know how to do this fast. Now, I had a PowerShell Saturday 3 weeks ago, and James Petty did the same topic, but I think he did deeper dive on less information, and I think that's the only way that you can really do this.
I think a good demo which portrays using slides over code was Mike Lombardi's session from Summit last year, where we went over the refactoring scripts and adding pester tests.
Mm.
It was all done with slides and images rather than code, and I think that worked a lot better in terms of the explanation over the code rather than actually seeing somebody type the code.
Mm.
And that it was actually after watching his session, I went back and refactored one of my presentations to remove the demos from it. And whilst presenting it, not only was I more comfortable because I wasn't having to live code in front of a room full of people, but it was much easier to explain what was happening in the code and answer any questions rather than sitting mashing the keyboard and making terrible spelling errors.
I'm a terrible typist, so
it's not a demo unless it gets red on the screen, is it?
Yeah. Well, you know, I had the ISC open before, and I typed those commands. That's because yesterday when I was doing this, I tried to type those out, and I just kept getting red on the screen. I'm like, what am I doing wrong? Oh my God, I'm going to look like an idiot in my own presentation. So
That was good.
Well, looks like there's no questions coming through, so I'll just thanks again, both Ed and Mike. Really appreciate it.
sure.
Thanks for having us.
You know what? 5 a.m. in the morning's not so bad. I might be tempted to do this again.
Oh, it's clearly still too early. He's mad.
Yeah. See, now you know how I feel every month with the tweet chats.
Mm.
Which reminds me, actually, we're having a second set of tweet chats for the Asia Pacific region, and it's coming up this Friday, and I need to figure out a hashtag, but I'll tweet about it.
Nice.
Maybe PS Tweet Chat APAC or something like that.
Yeah, I'm trying to think of something concise.
Yeah.
So that we're not using half of our character limits.
Yeah. All right.
Yeah,
well,
I'll tweet that out.
I had a ball doing this, guys. I hope you guys had fun. Go get some sleep or whatever you're gonna do, and somehow you gotta make it through a day of work now.
Good luck.
Take care, guys.
All right, see you later.
Cool. Thanks again.
All right. Okay.